Hello everyone. So today we're going to talk about relating limits to horizontal asymptote lines and limits with infinity. Okay, so what we're going to do first is try to connect end behavior of power and polynomial functions to limits. Alright, and so I know some of my students have studied this before, but if you're not quite familiar with this stuff, that's why I'm recapping it for you guys. Okay, so before we get started talking about limits, I just want to talk about how we can figure out the end behavior of power and polynomial functions. So first, let's just define what a power function is. So if you forgot what a power function is, it's a function of this form, f of x equals k times x to the p, where k and p are constants. Okay, and so here I provide you with an example, right? F of x is equal to 2x to the sixth. Okay, so how do we go about figuring out the end behavior of these functions? Well, here I have a summary chart that helps you sort of figure out for all power functions what their end behaviors are. So here in the first row, it's talking about when your k is positive, or the number in front of x. When that's positive and here we're talking about the power being even. The shape of the graph is going to look like an upwards U. And then here down below, it gives you the end behavior. So it's saying as x goes to negative infinity, f of x goes to positive infinity. And as x approaches positive infinity, f of x approaches positive infinity. Okay, and then over here on the right, if we have an odd power, but the number in front of the x is positive, then we have this shape here of the graph, and here below it we have the end behavior. So it's saying that as x goes to negative infinity, f of x goes to negative infinity, and as x goes to positive infinity, f of x goes to positive infinity. Okay, and then also on the second row, right, I give you the case when the number in front of the x is negative, and then the shapes of the graphs corresponding when the power is even and odd, and how that changes the end behavior. Okay, so these will help you in terms of trying to figure out the end behavior, because essentially I'll show you kind of what's happening to sort of understand a little bit better if you're really not familiar with this at all. As x goes to negative infinity, what it's talking about for the even power case when k is bigger than 0. So as the x values are getting more and more negative, like going towards the left, right, what's happening to the function is it's just keeps going and going upwards, right, towards positive infinity. So that's why it says as x goes to negative infinity, f of x is going to positive infinity. And so now looking towards the right of the graph, though, as x is getting bigger, what's happening to the graph? Well, the graph is still going upward, and so as x goes to infinity, f of x goes to infinity. Okay, so what I'm going to do here to do these practice problems is basically use this chart, and what I like to do is draw like a rough sketch or a rough shape of the graph. Okay, so kind of like what's drawn in the chart here. So it says to state the end behavior of each power function, then express your answer using limit notation. Okay, so for f of x equals negative 2x squared, I know that my number in front is negative, right? And that my power is even. Okay, so I should be looking at the second row here, because my number in front of x is negative, and then looking at the picture corresponding to the even power. So this rough sketch of the picture is going to be like a downwards U, right? And so I need to consider what's happening as x approaches infinity and as x approaches negative infinity. So as x is approaching infinity, looking to the right of the graph, what's happening to the function? Is it pointing upwards or downwards? And so hopefully when you're looking to the right, that you would say that it's pointed downwards, so it's pointed towards negative infinity. Now, if I look to the left of the graph, because I'm looking for as x approaches negative infinity, here looking to the left, I see that it's pointed downward again. So this would say f of x is approaching negative infinity. And so you can see that also, right, in this chart displayed right at the bottom. It gives you that end behavior as well. But just so you can see and visualize with a picture, so you don't have to memorize for each of these 4 cases what the end behaviors are, I basically use the picture to help me remember what they are. Okay, and then looking at part B, it says f of x is equal to x to the 7th. So note that since there's no number physically there in front of the x to the 7th, that it's just going to be 1, right? So it's really just 1 times x to the 7th. So I know that my k value is positive and my power is odd. So the shape of the graph, based on my chart, looks like this. Okay, and so as x is going to infinity, what's happening? What happens when I look to the right of the graph? So I'll highlight that in green. When I look to the right of the graph, I see that my graph is going upward, right? So f of x is going towards positive infinity. And when I look to the left of the graph, what's happening? Well, hopefully you would tell me that it's going towards negative infinity because it's downward, right? To the left of the graph, the function is approaching downward, and so it's going towards negative infinity. Okay, so now let's actually write these in limit notation. So here in my end behavior part, it's saying as x approaches infinity, the function's approaching negative infinity. So how I write that in limit notation is I just write lim as x approaches infinity, my function is approaching negative infinity, right? And then to write the limit as x approaches negative infinity, well, I already figured out what my function's approaching. It's approaching negative infinity. Okay, so that's how we would write it using limit notation. Okay, because remember the limit tells us what value the function's approaching or what the output values are approaching, right? And so, again, looking at this part, if I want to do the limit as x approaches infinity, looking right above, it says that my function is approaching infinity, so this would be the correct limit notation. And so for negative infinity, I would have that my function is approaching negative infinity here. Okay, so you want to make sure, I know we talked about limits algebraically a lot, and we might have forgotten formally what a limit is, but just remember, the limit tells us the function value that we're approaching as my inputs are approaching some number, or in this case, positive or negative infinity. Okay, so let's talk about what's going on here in practice 2. So here I just want to recall the following. So the end behavior of a polynomial, okay, is the same as the end behavior of the term with the highest degree. Okay, so in other words, if I know how to find the end behavior of power functions, then I basically know how to find the end behavior of polynomials. Okay, so looking at this example in practice 2, it says state the end behavior of the polynomial function below, then express your answer using limit notation. Okay, so the first thing we need to do is figure out what term has the highest degree. So hopefully you would say that the term with the highest degree is the one I just highlighted here, 4x squared. Okay, and so now I'm focusing on what's the end behavior of 4x squared. Well, the picture roughly is going to look like an upwards U, according to my chart. Okay, and so as x approaches infinity, looking to the right of the graph, where does my function approach? Well, as x is going to infinity, we see that the graph is going upward, right? And so it's going towards positive infinity. And then to the left of the graph, the function is still pointing upward, and so it's still going towards infinity. And we can see that here, right? So as x approaches negative infinity, f of x still is approaching infinity. And so just to reemphasize that limit notation, so I'm going to rewrite both of these using limit notation. the limit as x approaches infinity of f of x is equal to infinity, and then the limit as x approaches negative infinity of f of x is equal to infinity.